So today's lesson is 5.6. It's called the quadratic formula and the discriminant. So typically I divide this up into just talking about the quadratic formula and then the second day for the discriminant, but the discriminant is within the quadratic formula. So I think it'll be easy enough for us to combine into one lesson and to get done. Most of you know what the quadratic formula is anyway. So we're just going to review what that is and how to substitute in. In the beginning of this section in your book, it kind of goes through how to find that. We're not going to go through all of that. I just need you guys to know what it is and how to use it. So make sure this is something you will have to have memorized. I will not be giving this to you on a test or anything. You do have to have this memorized. Some of you know the song. I'm not going to sing it on here. If you want me to sing it in class, maybe we can do that together, but I'm not singing on the video. So let's take a look at some of these things here. So the quadratic formula is a formula that is used to solve quadratics of any capacity, whether it's imaginary roots, whether there's rational, irrational. Doesn't matter what the equation is, the quadratic formula will always solve the problem. So if you don't know if you can factor it or not, if it doesn't specify, you can always use the quadratic formula. And the quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And again, that a, b, and c comes from the standard format of the quadratic equation, ax squared plus bx plus c. So you need to kind of go through and label those a, b's, and c's first, and then plug them right into the equation. Let's go and take a look at our first example. It says solve x squared minus 12x equals 28 by using the quadratic formula. In order for us to do this, again, we have to set it equal to 0. So for completing the square, that's the one time where I said you don't want it equal to 0. For this one, we do want it equal to 0. So we have to start by subtracting 28 from both sides so that I end up with x squared minus 12x minus 28 is equal to 0. Now I have my a, my b, and my c on one side of the equation, and I can go ahead and identify those and solve it. So a is going to be 1 because there's nothing in front of the x squared, which indicates that there's a 1 there. B is going to be negative 12 because that's in front of the x term. And then c is always our constant, so that's going to be a negative 28. So we plug those into the quadratic formula. So it becomes a negative 12 plus or minus the square root of negative 12 squared minus 4 times 1 times negative 28 all over 2 times 1. We can reduce some of these things so that negative 12 just becomes a positive 12 plus or minus the square root of 144, and then negative 4 times negative 28 gives us a 112. We add those two things inside the square root first. You always work from the inside out. So we work inside there and we end up with a 256. The square root of 256 is 16. So now I have two separate problems. I have 12 plus 16 all over 2, and I have 12 minus 16 all over 2. So I have to solve two different things to get my two solutions. Because remember, quadratics always have two solutions. Sometimes they're the same, but there's always two. So I end up with 12 plus 16 over 2, which is going to give us 28 over 2, which is 14. And 12 minus 16 over 2, which gives us negative 4 over 2, which is negative 2. So our two answers are negative 2 and a positive 14. That's an example where we had two rational roots. They're both whole numbers or nice decimals. We're now going to go over where it has a double root. So that's the one, remember, we could have two roots, one root, or no roots. So now we're going to go through an example that's only going to have one root for us. Again, we want to identify our a, our b, and our c. This equation, x squared plus 22x plus 121 equals 0, is already equal to 0, so I don't have to do anything first. We can just identify our a, our b, and our c value. A is 1 again, because there's nothing in front of the x squared. B is 22, and c is 121. So we're going to go ahead and plug those things into the quadratic formula so that I have x equals negative 22 plus or minus the square root of 22 squared minus 4 times 1 times 121 all over 2 times 1. When I reduce the things on the inside of the square root, we end up with a negative 2 plus or minus the square root of 0. Because that 22 squared minus the 4 times 121 is going to give us 0. Well, the square root of 0 is 0, so there's nothing to add or subtract there. We're left with just negative 22 over 2, which is a negative 11. And remember, the double root there indicates that the vertex lies on the x-axis. So it only intersects it once, and that would be at the vertex. For us this time, that would be at a negative 11. Looking at this next example, 2x squared plus 4x minus 5 equals 0. This problem has an a value, so that's a little different than the last one's happened. It's already set equal to 0. So let's go ahead and plug into the quadratic formula. Again, these are all pretty much just plug and chug. Once you identify a, b, and c, you're just plugging into the quadratic formula. So we have x equals a negative b, so that'll be negative 4, plus or minus the square root of b squared, so that's 4 squared, minus 4 times a, which is 2, times c, which is negative 5, all over 2 times 2. So when I simplify that, 4 squared is going to give me 16. Negative 4 times 2 is negative 8, times negative 5 is going to give us a positive 40. So when I add that all together, we end up with a positive 56. So we have the negative 4 plus or minus the square root of 56 all over 4. Now with this, 56 is not a perfect square. Now it has a perfect square within it, which is 4. So we can take the square root of 4 and give us 2. So I can factor that out to give me negative 4 plus or minus 2, the square root of 14 all over 4, or negative 2 plus or minus the square root of 14 all over 2. I can reduce those three values, the 2 of them on top and the bottom one, all by 2. So the negative 4 is divided by 2, the 2 is divided by 2, and the 4 is divided by 2. Notice I did not divide the square root inside the square root. That is untouchable. So that, even though it was divisible by 2, could not be divided because it's inside the radical. Everything else has to match. You can't do it with just 2 or just 1 or whatever. You have to be able to do it with all three of those numbers. So I reduced that to negative 2 plus or minus the square root of 14 all over 2. That's it. That's where you can leave it. I'm not worried about decimal approximations unless they specify that they want decimal approximations. This is the exact solution. We're not rounding off or guessing. So this is where you can leave it. You do not have to give me the decimal formats of those. You can if you want. It's not wrong, but you do not have to. For this last example, again, I have to get it set equal to 0 because I have x squared minus 4x is equal to negative 13. I'm going to add that 13 to both sides so that we have x squared minus 4x plus 13 is equal to 0. And now I can plug in my a, my b, and my c values. My a is 1, b is negative 4, and c is 13. So I have x equals a negative negative 4 plus or minus the square root of negative 4 squared minus 4 times 1 times 13 all over 2 times 1. Now the negative negative 4 reduces to just 4, plus or minus the square root of negative 4 squared is 16. Negative 4 times 13 is a negative 52. So 16 minus 52 gives me a negative 36. Now notice we have a negative under the radical. That indicates that we're going to have to use an I value. So yes, there are times where you're going to get I values, but the quadratic formula can help you find those. Just because it's a quadratic formula doesn't mean you can't find them. So that's going to end up being 4 plus or minus 6i all over 2. Again, you can reduce it, but all three of those numbers have to reduce. So the 4, the 6, and the 2 all have to reduce together. Divide them all by 2. So I end up with 2 plus or minus 3i. And that is your final answer because you have 2 plus 3i and 2 minus 3i. We can't combine it because it's with the i's. So that's all the further we can take it. So now we're going to get into this thing called the discriminant. The discriminant is simply the value underneath the radical of the quadratic formula. So it is just the expression b squared minus 4ac. When you figure that out, what that's going to give you is it's going to give you the number and type of roots of a quadratic equation. It's going to tell you whether they're real or imaginary. It's going to tell you whether there's 1, 2. It's going to give you the value and type of root of the quadratic equation. So by us finding this, it kind of gives us insight into the equation and the solutions of the equation before we even have to solve it using the quadratic formula. So by doing that, we're kind of giving ourselves a heads up as to, am I looking for 1 solution, 2 solutions, no solutions, imaginary solutions. So we'll be looking for those types of things as we look at the values of the discriminants. Let's go ahead and look at taking an example of finding the discriminant. For this first example, it's giving us 9x squared minus 12x plus 4 is equal to 0. So we still need to identify our a, our b, and our c values, which for us, a is going to be 9, b is negative 12, and c is 4. So when I plug that in, we're going to end up with a negative 12 squared minus 4 times 9 times 4. And when I evaluate that, we're going to end up with a positive 144 minus 144, which gives us 0. Well, if you remember, if we have a 0 under the radical, that means we're only going to have one solution. So for this particular equation, it's telling us we have one real rational solution. For this last example, it's 2x squared minus 16x plus 33 is equal to 0. Again, we're identifying our a, our b, and our c values. A is 2, b is negative 16, and c is 33. When I plug those into b squared minus 4ac, we end up with negative 16 squared minus 4 times 2 times 33. That gives us 256 minus 264, which is a negative 8. Because it's a negative, that means we're going to have a negative under the radical, which means we have two complex or imaginary solutions for this particular quadratic. So the answer that we would get in the end would end up involving I to some extent. And here's your homework assignment for this section. It is page 281, 15 through 24, along with 28. This is kind of a combination of both of them that was listed on the calendar. So I've combined those so that we can kind of move through this chapter a little more quickly. And in the homework, they're going to ask you to go through parts A, B, and C. Part A being to find the discriminant. Part B, identifying the type and number of roots. And then part C being to actually solve the quadratic. So when you do that, you're going to find the discriminant just like we did in this last example, identify the number and type of roots, and then you can plug that directly into the quadratic equation when you do your homework. So don't do that all over again when you go to solve the quadratic. Save yourself those steps. You've just solved part of it. Plug that right into the radical, and then you can simplify from there.